Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 24th video in the Introductory Programming in Java full course and the 7th video of Lesson 4, Looping Structures in Java. So far, we've covered loops in Java pretty thoroughly. What we're going to talk about in this video is how to read from a text file with a loop. Let's get right into it. A text file is a file that contains data that is meant to be interpreted as characters, and that is all it contains. It is a very simple file format, a series of characters without any additional information such as font, formatting, or embedded images. Our Java programs are stored as text files, and you've maybe written a document and saved it as a plain text file. Quite often, data that is used in scientific studies is stored in plain text files. Reading a text file with a Java program means taking the information that's in the file and storing it in variables in a program, and usually processing it in some way. Let's begin with how to read from a text file, what classes to use, how to use them, and where in your Eclipse project to put the text file you want to read from. I will start by creating the text file. In Eclipse, I will right-click on the project folder. My project folder is called Lesson 4. And I will choose New File. And a Create New File dialog box comes up. It has Lesson 4, my project folder, selected, but if it didn't, I would click on my project folder. And I'm going to call the file sample.txt, and I'll click Finish. Now notice I have a window called sample.txt that I can edit, and look in the Package Explorer at where my file is. It is in the Lesson 4 folder. It is not in the SRC folder or the default package folder. If I close everything up, you can see it's right under the SRC folder. Let's look at it in the System Explorer. I'll right-click on it and choose Show in System Explorer. And the window opens up, and you can see it right in the Lesson 4 folder. If we want to read a text file using just the name of the file in our Eclipse project, that is where we should put it. If you're executing a program at the command line, then you would drop the text file into the same directory as your binary file, which is probably going to be the same directory as your source file. Everything goes in the same directory. In Eclipse, it goes in the project directory. Okay, let's put something in this text file. I'll put in some text, hello world. And I'll press enter, and then I'll put in a number. How about 2024? Okay, and I'll save that. Now, let's write a Java program to read from the file. We will use the file class in Java to create a link between our program and the file. A file object doesn't actually contain the file's data. It provides methods to interact with the file or directory it points to. For example, you can use the file class to check if a file exists, create a new file, delete a file, or get information like its size or last modified date. It's a way for your program to interact with the file system. We'll use the scanner to read from the file. I'll create a class called simpleread.java. And I'm going to import java.io.file and java.util.scanner. We'll need to import one more class, so we'll come back to the imports in a moment. Let's have a variable declaration area here at the top of the main method. I'll declare file. Since this is just an example, there isn't much meaning to our file, so its name is simple, and I'll declare scanner fileIn. In the past, we've called our scanners standardin because they are attached to standard input. This scanner is going to be attached to our file, so I'm calling it fileIn. Now let's have a comment, and we'll create the file object. We pass as an argument to the constructor the path to the file. So create a file object to reference the file, and then file equals new file, in quotes, sample.txt, semicolon. Our file is in the same directory as our program, at least that's how it's treated by Eclipse. So the path is simply the file name. Remember that a file name or file path is a string. It's text. Some learners confuse the file name with the object that references the file, the object that lets us get at the file contents. Remember, the file name is just text. The file variable is our reference to the file in the directory. And after we've created the file object, we can use it to check if the file exists. Maybe it doesn't, if we got the name wrong, or if somebody deleted it and then tried to run our program. And also as an input stream for the scanner, the thing the scanner will read from. So let's have a comment, read the contents from the file, if it exists, and display them. Then we'll write if file.exists. That's a method, so open paren, close paren. And if it doesn't exist, we're not going to do anything. The rest of our program will be within the curly braces after if file.exists. We'll create the scanner, read the string and the number, close the scanner, and print the values. I'll put some comments in for each of these steps. To create the scanner, fileIn equals new scanner. And as an argument, we'll pass in the file object. That's the input stream that the scanner is going to read from. Now, ignore the red X for a moment. We'll come back to that. Remember everything you know about the scanner. It applies to reading from a file the same as reading from standard input. If we read a token with next int, next double, next byte, next, etc., it will take the next token from the input stream. Tokens are delimited by whitespace. The next methods leave the whitespace in the input stream. If you use next line, the scanner will read everything up to a new line. I'll link a video here about the scanner if you're not familiar with it or need a refresher. Therefore, to read a string, because we don't know if it contains whitespace, but we do know there's a new line after it, we'll use next line. So text equals filein.nextLine. I'd better declare a variable text. And let's declare an int number, and then number equals filein.nextInt. I'll then print the string and the number that we read from the file, and then I'll close the scanner. Now, we can't run it yet because of the red X. Let's mouse over it. It says, unhandled exception type, file not found exception, and that's on the scanner line. If we try to point the scanner at a file that doesn't exist, the scanner constructor will throw an exception. We're not going to talk about exceptions yet, except to say, when a method we call throws an exception, we either have to handle the exception by catching it, or we ourselves must throw it. We're going to throw it. You do that in the header of the method that is on the receiving end of the exception. So after public static void main string args, I put throws file not found exception. And you can see that throws is a keyword. And that gives us a new red X, and that's because we need to import the exception. So up in the imports, I'm going to type import java.io.filenotfound exception. And if I run this, it successfully reads Hello World and 2024 from our file and prints them out. Now let's look at a more complicated example, one that uses a loop. Here's a text file called aiinvestment.txt. This is a file that I've modified from data downloaded from ourworldindata.org. This data reflects the amount of money spent in different sectors on artificial intelligence between the years 2017 and 2021. This is only some of the data. When we're reading from a file, it's important to understand how it's organized. Otherwise, you can't process it. This is organized into records. 3 lines of data represent 1 record. The first line is the category of the sector. For example, agricultural tech, audiovisual, augmented reality. The second line is the year, and the third line is the amount spent on AI that year. So if we're going to read one record, we'd read in that order: name, year, amount, string, int, long. Some of these numbers are too large to fit in an int. But normally we don't write a program that has a read statement for every line of a file. Usually the file has too many lines, and quite often we don't even know how long it is. So we read in a loop. We read until we reach the end of the file. If the file is organized into records, we usually read and process one record each time through a loop. The scanner has a Boolean hasNext method, which returns true if there's anything left in the file. So we can use that to control a while loop, conditional loop, that reads until the end of the file. Suppose further that we'd like to calculate the average amount spent for 2021. Then we'd need an accumulator to add up the amount spent, but only if the year is 2021, and we'd also need to count how many 2021 records are in the file. I have a program here that does those things called aireader.java. Let's take a look at it. The imports are the same as our last program. Lines 23 through 28 are also basically the same as the last program. We create a file object using the name of the file. We then check if it exists, and if it does, we create a scanner. But now, this program is going to read and process the contents of the file in a loop. So this is quite different from the last program. On lines 31 and 32, we're initializing our accumulators to 0. The accumulators are expenditures 2021, which will hold the total amount spent in 2021, and num 2021 records, which will count the 2021 records so we can calculate an average. Line 33 is the top of our loop, while filein.hasNext. I am making an assumption here that the file will contain complete records, that it won't end with a partial record. After that, we read a category, a year, and an expenditure. That's pretty simple. We're using the scanner and next line for the string, and next int and next long for the two numbers. But after that, I have if filein.hasNext, filein.nextLine. Do you know why that's there? Remember that next long will read a token and leave white space. We need to consume that white space before we come back up to the top of the loop and read our next category with next line. Otherwise, next line will simply read the white space left in the file after the expenditure value, and our reading will get out of sync. You can put a breakpoint in, comment out line 39, and step through this in the debugger to see what I mean. It'll crash on line 36 on the second record, so you won't have to step through too many times before you encounter the error. So once we've read a record, I print it with a pretty bare bones print statement, just the values still limited by commas. And then we check if the year is 2021, and if it is, we add expenditure to expenditures 2021, and we increment num 2021 records. And that's it. To construct a loop that reads records from a file, use hasNext to control the loop, read a complete record, make sure you consume a new line. Anytime you're switching between token reading and using next line, even if it's between executions of the loop, and then process your complete record. Once we're out of the loop, but still in the if file exists code, if there were any 2021 records, we calculate and display the average. Note a couple of things about that. We want to check that there were 2021 records because if there weren't, we would divide by 0. And we're casting one of the operands in the division to a double, so we're not performing an integer division. Finally, we close the scanner. Again, we want to make sure this is within the if file exists code, because that's where we created the scanner. Now, you may have written programs similar to this that process input from the keyboard, and this is not that different. The only difference is we're pointing our scanner at a file instead of standard in, and we're using the scanner's hasNext method to control the loop. It peeks ahead in the file and sees if there's anything for us to read. If there isn't, it returns false, and we drop out of the loop. I know file reading can feel intimidating, but the basics are straightforward. If you're new to loops, then I think the combination of loops and files can be a little tricky. Use the debugger to step through your program whenever you're having trouble, because it will help you see how your loop is functioning. As usual, I have included some auto-graded exercises in the description of this video so you can practice with the video code, and the code has been uploaded to my GitHub repository. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.